CB 91, CB 91, 92. Again, some students are sending their attendance to chat box. Why? Why are you sending your attendance to chat box? It creates lot of problems. I have told you, repeatedly I have told you, please don't send your attendance to chat box. It, 91, CB 91, 92, 93. Computer Science 6060, Computer Science 6060, Computer Science 63, Computer Science 68, Electrical Engineering 49, Electrical Engineering 49, 50, 50, Electrical 50, 50.
Ma'am, in the meantime, could you mark me? It is AMB 025.
Sorry? What
Ma'am,
are
in
you
the
telling?
meantime, could you mark me? I am AMB 025. Could you mark me present?
Yes. AMB is 025. Yes, I have marked present. Okay?
No, thank you, ma'am.
Ma'am, what about CSB 070?
CSB 070 is present.
Ma'am,
Thank you, ma'am.
Chandri,
ma'am, hello.
Yes, ma'am.
actually, please, I first. Again, what are you telling? Please wait a few minutes, just a few minutes. Please wait. I am checking and then please, after just a few minutes, you tell me. I am checking. Second time I am checking. Electrical 55, electrical 56, electrical 55, electrical 56. Electronics 41, electronics 41, 41, electronics 41. Mechanical 49. Mechanical engineering 49. Mechanical engineering 49. 51. Mechanical engineering 51. Mechanical engineering 53. 53. Mining 25. Mining 25. Oh, another thing. Metallurgy 30. Metallurgy 30. Mining 25. Okay, so I have called only the absent roll number, and do you want, then I can again call. Otherwise, I will start. Will I call? We just repeat the absent roll number. Just a minute.
Yes, yes, ma'am.
Okay, civil engineering 78. Then civil engineering 91, 92, 93. Computer science 60, 60. Computer science 63, 68. Electrical 49, 50, 50. 55, electrical 55, 56, electronics 41, mechanical 49, mechanical 51, mechanical engineering 53, then metallurgy 30, 30, mining 25. Okay, these are absent. These roll numbers. These students are absent. Now I start. Okay.
Yes, ma'am.
Now I share the screen. Just a minute. Is it visible?
Yes, ma'am.
Okay. Okay, now you see how to find the particular integral of this differential equation. Okay, it is easy to find out the complementary function. So just we find out the particular integral. Now you observe the particular integral is 1 by fd. Fd means here d square plus 4. This is fd. Okay, 1 by fd operating on capital X. Capital X means the function on the right side, that is sine 2x. And you know the formula for finding the particular integral where the right side function is sine or cosine ax. What you have to do, just d square will be replaced by minus square of this coefficient, that is minus 2 square. But you see, if in the denominator d square is replaced by minus 2 square, where 2 is the coefficient of x in the sine function, then denominator vanishes. So in this case, this method cannot be applied. This rule cannot be applied. So if the denominator becomes 0 when this function is sine or cosine, and if you replace d square by minus t square, the denominator becomes 0, then you use this method what I will tell you now. You see this sine function or cosine function, whatever may be, that can be expressed in terms of exponential function like this. You know, sine 2x is 1 by 2i into e to the power 2ix minus e to the power minus 2ix. If it is cosine, then also it can be expressed in terms of exponential functions. Now you see, just we replace this sine function by this. Just you see, sine 2x is replaced by this. Then what will you do? Just you break this into two terms. One is e to the power 2ix, another term is e to the power minus 2ix, like this, you see. E to the power plus 2ix, e to the power minus 2ix. Actually, if we calculate this 1 by d square plus 4 e to the power 2ix, then just replacing plus I by minus I, you can obtain the value of this. So now we are to compute the value of this only. After that, just if we replace plus I by minus I, then you can obtain the value of this. First we calculate the value of this 1 by d square plus 4 operating on e to the power 2ix. You see, again you see, if the function on the right side is exponential function, the rule states that d will be replaced by 2i, where 2i is the coefficient of x in the exponential function. Suppose it is e to the power ax, where a is the coefficient of x in the exponential function, then this d will be replaced by a. This is the rule for finding the particular integral where the function is exponential function. Now here this coefficient of x is 2i. So if we replace d by 2i, what happens? You see, d is replaced by 2i means minus 4, because d is replaced by 2i. 2i whole square means minus 4. So minus 4 plus 4, denominator again becomes 0. So you cannot use this rule directly. Then what you have to do? You have observed this situation. If if this function is exponential function, and if this d is replaced by this 2i, and if the denominator becomes 0, then we write this e to the power 2ix as this into 1. 1 is actually written as x to the power 0. So it is of the form, you see, e to the power x into v form. E to the power x into v form, where v is considered here x to the power 0. Now we apply this rule 1 by fd e to the power x into v, where you see this exponential function is taken outside this operator like this. E to the power 2ix is taken outside the operator this, and d will be replaced by d plus a. Is here 2i. So this d will be replaced by d plus 2i, like this. D is replaced by d plus 2i. But v remains unchanged. Only you just use this rule. E to the power x has been taken outside the operator and d is replaced by d plus a. You see, d is replaced by d plus a like this, but v remains unchanged. We use this rule here. Just d is replaced by d plus 2i. E to the power 2x has been taken outside the operator, but v means here x to the power 0, remains unchanged. Now you see, here you see, just to simplify this denominator, so it is d square plus 4id, 4di, minus 4 plus 4, again minus 4 plus 4 will be cancelled and we obtain this d square plus 4di operating on x to the power 0. You see, operating on x to the power 0. Now you see, this, if we take common d in the denominator, then it becomes, actually, you see, this 4di should be taken common. Why? 4di, why is it taken common? Because you know, since it is x to the power m type, x to the power m type, so this fd should be written in the numerator with negative index and then expand in ascending powers of d. Just you see the rule where it is x to the power m type function. Then what you have to do? Just fd in the new denominator will be written in the numerator with negative index and then expand in ascending powers of d. This is the rule. And so you know, for negative index, the binomial should be 1 plus x or 1 minus x. So you have to take common 4id to make this 1. Just you have to make 1 in the binomial 1 plus x or 1 minus x type. So we should take common 4di in the denominator and then you can obtain 1 plus d by 4i and then it is written in the numerator with negative index. So it becomes 1 plus d by 4i whole inverse. But v remains unchanged like this x to the power 0. Just you see, x to the power 0 remains unchanged. Now you expand this binomial with negative index in ascending powers of d like this. Just you expand this. And now we apply 1 into x to the power 0, that is 1. This is d. D stands for d dx, first order derivative of 1. Then d square means second order derivative of x to the power 0. All other higher order derivatives of x to the power 0 is 0. Because x to the power 0 means 1. Only the first term 1 into 1 will survive. But first order, second order and all other higher order derivatives of constant 1 is 0. So only one non-vanishing term is 1. Now you see 1 by d operating on 1. You see that is actually this is 1. And you know 1 by d operating on 1 means integral of 1 with respect to x. That is x only. So this value is actually x. 1 by d means integral with respect to x. Of integrand is 1, x to the power 0 is 1. So integrate 1 with respect to x, that is x only. So it becomes x e to the power 2ix by 4i. Yes, this is the value of this is this x by 4i e to the power 2ix. And now if we replace plus I by minus I on both sides, then what we get? 1 by d square plus 4 e to the power minus 2ix equals to x by this plus I will be replaced by minus I and that is written here and e to the power minus 2ix. E to the power minus 2ix. Okay. Now you put these values in 1. 1 means you see, just you see, this is 1. We have computed the value of this as well as the value of this. Put these values in 1 and then we obtain this. You see this. Just you put the values of 1 by d square plus 4 operating on e to the power 2ix and 1 by d square plus 4 operating on e to the power minus 2ix. If you put these values in 1, then we obtain this. Now you see, I square is minus 1. So it is minus x by 4. If we take 2 here, so e to the power 2ix plus e to the power minus 2ix all divided by 2. Actually, this is cos 2x. The expression within parentheses denotes cos 2x. So it becomes 1 by d square plus 4 operating on sin 2x is actually minus x by 4 cos 2x. if you use some shortcut formula, then it is actually x by 2, x by 2 integral of sine 2x. Integral of sine 2x is actually minus cos 2x by 2. But this is the deduction. This is the deduction how to obtain this. 1 by d square plus 4 operating on sine 2x equals to this. So what is your observation? Just you observe very carefully that in this case, when we replace d square by minus 2 square, denominator becomes 0. In that case, we express sine or cosine function in terms of exponential functions like this. Just we put the value of sine or cosine function in terms of exponential functions, and then we first compute this. The value of other term may be easily obtained by replacing plus I by minus I. So just compute this. Now here you see if it is exponential function, then and d will be replaced by 2i, and you see if d is replaced by 2i, the denominator becomes 0, so you cannot apply that rule directly. So you consider this as e to the power x into v, where v is considered 1, that is x to the power 0. And then we apply this rule, just to use this rule, 1 by fd to the power x into v equals to this. After applying this, again you see this is x to the power m type. X to the power m type function means the denominator fd should be written in the numerator with negative index and then expand this binomial for negative index in ascending powers of d. And then you apply this on x to the power 0, that is constant. And since it is 1 only, so first order derivative and all other derivatives of 1 will be 0. So only non-vanishing term is 1 into 1, that is 1. So 1 by d operating on 1 is actually x. You know, this is the value. 1 by d operating on that is x. So put this value x and simplify. We obtain this. Similarly, replacing plus I by minus I, we obtain the value of 1 by d square plus 4 d to the power minus 2ix equals to this. And finally, in 1, you have to put the values and obtain this as minus x by 4 cos 2x, because this is cos 2x. Now this can be taken as homework, because we have computed here d square plus 4 operating on y equals to cos 2x. So you can easily compute d square plus 4. We have computed this for sine 2x function, and homework is when it is cos 2x. And you know what is the value of cos 2x? You see, e to the power 2ix plus e to the power minus 2ix divided by 2. That is very simple. And the process remains same as in problem 5, what we have done just now. Now you see another form where capital X means the right side function. The function on the right side of the differential equation is x to the power v, or x to the power n into v. Okay. Then the rule where v is any function of x, where v is any function of x, or v is any function of x only. Okay. And n is a positive integer. N is a positive integer. And v is any function of x. Now you see 1 by fd operating on x into v, which is actually x minus 1 by fd, f dash d, then 1 by fd operating on v. And when it is x to the power n, same as before, only raised to the power n. If it is x to the power n, then this is raised to the power n. If it is only x power 1, that is 1, power 1, then the formula is this: x minus 1 by fd into f dash d. Am I audible?
Yes, ma'am.
And the screen is clearly visible?
Yes, ma'am.
Okay, okay. Now you see the another formula where the right side function is x into v, or x to the power n into v, where v is any function of x, and here n is a positive integer. Now you see, if it is x into v, the formula is this: x minus 1 by fd. This is f dash d, that is first order derivative of fd with respect to d. And this is 1 by fd operating on v. And if this x to the power n into v, the right side function, then the formula is slightly changed. You see, this is raised to the power n, but other parts remain same as before. Okay, so it is more general form where if you put n equals to 1, then you can obtain this E, part E. Part B is more general, and then if you put n equals to 1 to obtain part E. Now you see, if you solve this problem, use this actually. X into v, where v is a function of x, which is sine square x. So sine square x may be replaced by 1 minus cos 2x whole divided by 2. Then just you break x into 1 minus x into cos 2x. Okay. Now you see, this, if it is x, that is same as before, x to the power n type, then you know this denominator will be written in the numerator with negative index. And since it is a binomial having negative index, then the binomial should be 1 plus x or 1 minus x type. So we have taken common 4 in the denominator to obtain 1 in the binomial, 1 plus x whole inverse. Then you expand in ascending powers of d, and you see this is x only. So 1 into x, this will survive. This will be non-zero term, but other terms like second order derivative and all other higher order derivatives of x will be 0. So it is only 1 into x, that is x. And you see, we have applied rth order derivative of x equals to 0. If the order of the derivative r is greater than the degree of the variable, you see, x to the power 1, n is 1. So this derivative will be 0 if r is greater than 1. Like this, r is greater than 1. Now you see, we have computed the value of this, but we have to compute the value of this. 1 by d square plus 4 operating on x into cos 2x, you see. Now it is of the form x into v, v is cos 2x, which is a function of x. Okay, let v equals to this. Now use this formula x minus, you see, the formula is this. X minus 1 by fd into f dash t. That is first order derivative of fd with respect to d. And then it is 1 by fd into v. You see, x minus 1 by fd means d square plus 4, into f dash t, derivative of d square plus 4 with respect to d means 2d only, 2d. You see, 2d. And then it is 1 by fd operating on v. V means here cos 2x. V here is cos 2x. X into v, v means cos 2x. Now you see x minus 1 by fd. Fd means d square plus 4. And this is f dash d, which is 2d. Derivative of fd with respect to d is 2d. Again 1 by fd operating on v. Just we have applied the rule. Okay. Now you see 1 by d square plus 4 operating on cos 2x. We have already computed this in the previous problem actually. We have computed 1 by d square plus 4 sine 2x, and this is given as homework, the formula, and that is the method remains unchanged, and the result will be this x sine 2x by 4. Just we have used this result. Okay. Now you see x into x sine 2x by 4. So it is x square sine 2x by 4. And then it is minus, you see, this d operating on this function x sine 2x. Okay, you see, d operating on x sine 2x. Okay. D of x sine 2x means actually first order derivative with respect to x of x sine 2x, like this. Just you differentiate this. Next, you see 1 by d square plus 4 operating on this. Again, we can break this into two terms. 1 by d square plus 4 operating on 2x cos 2x plus 1 by d square plus 4 operating on sin 2x. Now it is minus, so it should be minus 1 if you break the terms. So it becomes like this. Now you see 1 by d square plus 4 operating on sin 2x, we have already computed, the value becomes this. Value becomes this. Already we have computed this. Minus x cos 2x by 4 is the value of 1 by d square plus 4 sin 2x. Okay. And now you see, already we have assumed that v equals to 1 by d square plus 4x cos 2x. So you just put value here, 1 by d square plus 4x cos 2x. That is v. Okay, 1 by d square plus 4x cos 2x is v. And already we have computed the value of 1 by d square plus 4 sin 2x, which is this. Okay. Now you see, minus v should be taken on the left and it becomes 2v. And other terms remain unchanged. Just to simplify this, v becomes this. And particular integral is actually, you see, particular integral is actually this. We've obtained from, just you calculate, that means the values should be substituted in one. This, already we have computed this. Now we have computed this, put these values in one to obtain the particular integral. You see. Already we have computed the first part, whose value is actually x by 4 and multiplied by half into x by 4 minus half into this value we have just computed. Okay, then it becomes this. You see, okay, minus half into this. So minus 1 by 16 x square sin x minus 1 by 32. Okay, minus half into this. You see, just verify, minus half into this. Okay, all these values should be substituted in one to obtain the particular integral. And similarly, you can compute the particular integral of this differential equation where the right side function is x square cos 2x, which is actually x to the power n. Just you see, we have computed by using this formula, and if it x square means x square means x to the power n, where n is 2, so we have to use this formula. Okay. But I think this formula may not be used. Can you tell me this formula may be avoided? Because if you replace cos x by e to the power ix plus e to the power minus ix whole divided by 2, then I think this formula may be avoided. And that I think that that formula may be simpler than this formula. Okay, you may avoid this formula by replacing cos x by its exponential values, like e to the power ix plus e to the power minus ix whole divided by 2. That formula will be easy to calculate. You can use this formula very easily. Now you see another type of linear equation, differential equation, homogeneous linear equation. Just you observe the form of this equation. X to the power n dny dxn plus p1 x to the power n minus 1 dn minus 1y dxn minus 1. Last term plus but 1 pn minus 1 x dy dx plus pny equals to fx. Call this equation number 1. You see, just you observe. Order of the derivative is n, where the degree of the variable is n. So order of the derivative and the degree of the variable are the same. Similarly, you see in the second term, order of the derivative is n minus 1 and the degree of the variable is n minus 1. Similarly, x dy dx, order of the derivative is 1 and degree of the variable is 1. And this is a special type of differential equation which is known as Euler's homogeneous linear equation. You see, we have considered the differential equation with constant coefficients in the previous cases. But now you observe the way the coefficients are not constants here. But if we use this transformation x equals to the power t, that means t equals to log x, dx dt is e to the power t, that is x, and dt dx is therefore 1 by x. If we use this transformation, then these differential equation can be transformed into a differential equation with constant coefficients. And so the differential equation with variable coefficients, which is known as Euler's homogeneous linear equation, can be transformed into a differential equation with constant coefficients if we use this transformation. Very special type of differential equation is this, which is known as Euler's homogeneous linear equation, and that can be transformed into a differential equation with constant coefficients by using this transformation x equals to e to the power t. X equals to e to the power t means t equals to log x, and so you see if we compute dx dt, that is e to the power t, which is x, e to the power t is x, and you see dt dx is 1 by x. Now we consider this differential equation, and you observe this differential equation. Just you see order of the derivative same as this, degree of the variable. Again you see order of the derivative is same as the degree of the variable. Order of the derivative same as the degree of the variable. So it is Euler's homogeneous linear equation. Now you use the transformation x equals to e to the power t, so t equals to log x, dt dx is 1 by x. So we have to compute actually why here why is the why is the dependent variable, it depends on x. You see, you calculate dy dx, then calculate d2y dx2, then calculate d3y dxt, and then put these values in the original differential equation. You see, dy dx means dy dt dt dx, and you see dt dx is 1 by x, so it is dy dt dt dx. Dt dx is replaced by 1 by x. Next, so it is x dy dx, which is dy dt. Now you see capital B stands for ddx, so it is x capital dy ddt is denoted by theta. Here, just we have used this notation theta. Some authors use some different notations. Theta is here dd. Capital D stands for ddx and theta stands for ddt. So it is x capital dy equals to theta y, where theta stands for ddt. Capital D stands for derivative with respect to x, and theta stands for derivative with respect to t. Again, calculate d2y dx2. Calculate d2y dx2. So you see dy dx is 1 by x into dy dt. So d2y dx2 is product of two functions. If you differentiate this, you see d dx of dy dx, that is d dx of dy dx is 1 by x dy dt. I have computed all these calculations to help you. Now you see product of two functions. So we apply the formula for finding the derivatives of product of two functions and obtain this. So just simplify this, x squared d2y dx2 equals to d2y dt2 minus dy dt. Now you see dt dx is 1 by x, we have used here. dt dx is 1 by x, we have used here. Okay. Now you see this is actually x squared d squared y. This is actually d dt stands for theta, so it is theta squared y minus theta y. So theta square minus theta whole operating on y. So x squared d squared y should be replaced by this theta minus 1 into theta. Similarly, you compute the third order derivative of y with respect to x. Similarly, you see. Just you will check these computations, please. Third order derivative becomes this. So we have computed third order derivatives, which is this actually. Third order derivative becomes this. You see, third order derivative becomes this. Now you see all this will be substituted in this x cube d3y dx3 plus 3x squared d2y dx2 plus x dy. All this, you see x dy dx should be replaced by dy dt. X squared d squared y x squared d2y dx will be replaced by this theta square minus theta operating on y, like this. So you see we have used this here, and after simplification it becomes very simple, which is a differential equation with constant coefficients. And you see here theta stands for d dt, so it is actually d3y d3y dt3 plus 8y equals to 65 cos t. Again, you see the same differential equation with constant coefficients, and the right side is cosine function, and so it is known to you already. We have considered this type of differential equations, and so you see first compute the auxiliary equation. Okay, theta is replaced by m, and by computing the values of m, you see one root is minus 2, other two Roots are pair of complex conjugate roots. Okay. Now you calculate complementary functions same as before. If there exist three roots, one root is -2, other two roots are you see 1 plus minus root 3. So use the formula for finding complementary function. Already it is done, and particular integral same as before. You see here, since the right side function is cosine function, coefficient of t in the cosine function is 1. So theta square will be replaced by -1 square. You see, use this. Theta square should be replaced by -1 square. But here it is theta cube. So we consider this as theta square into theta. Theta square into theta. So theta square is replaced by -1. So it is minus theta plus 8. Like this. It's like this. Like this. And now you see you have to make the denominator as a function of theta square. So we both multiply numerator and denominator by 8 plus theta to obtain denominator as a function of theta square. Now you just multiply both numerator and denominator by 8 plus theta, and so theta square denominator becomes 64 minus theta square. Now theta square is replaced by -1 square, and so it becomes 64 plus 1, that is 65. And then this 65 will be cancelled from numerator and denominator. You see, after simplification, 8 into cos t plus theta. Theta means here dt, derivative with respect to t. That of cos t is minus sin t. So the general solution is complementary plus particular, complementary function plus particular integral, same as before. Now you see, this is just a very special form. If you compare this differential equation with the previous one, just you see here, it is a plus bx. Instead of x to the power n, it is a plus bx. Just you observe, if you compare this differential equation with the previous one, only x is replaced by a plus bx everywhere. In that case, in the previous occasion, you have used this transformation x equals to e to the power t, but here x is replaced by a plus bx. If you observe very carefully, a plus bx whole to the power n. So order of the derivative and or degree of this a plus bx are the same. Just it is a plus bx. Only difference is this. So a plus bx will be replaced by e to the power t. Same other process remains unchanged. Just you use this transformation 5 plus 2x. If you compare this equation with the previous one, order of the derivative and degree of 5 plus 2x remains the same. Here, instead of the previous one, we just use the transformation 5 plus 2x equals e to the power t, and then the other method remains unchanged. Already I have discussed in the previous problem. I will send this course material to all of you. Thank you.
Thank you,
Thank you,
ma'am.
ma'am.
Okay.
Thank you, ma'am.
Okay, I leave now. I will send this, and you,
Thank you, ma'am.
Thank you, ma'am.
Thank you,
all of
ma'am.
you, please take the computational parts very seriously. If there is some typographical error, you please contact me. Okay. Okay. Thank you, all of you. I leave now. Okay, I leave now.